Welcome to Maths with EJD. In this video, we're talking about Laplace transform for systems of differential equations. And like we've always known, the Laplace transform is a powerful tool for solving systems of differential equations. We've been solving all kinds of equations, so it can also handle systems of differential equations. So as we know, it converts differential equations which may be hard to solve directly into algebraic equations in the Laplace domain. So this makes it easier to solve. And then the inverse Laplace, the inverse Laplace transform is used to return to the time domain, to return to the time domain. Okay. Um, so I'll just go straight and take an example. Of course, the steps are usually the same kind of steps, that we've been taking for the rest of them, you know. Um, so let's just go for that directly. Example, solve the x dt plus x of t equals 2y of t, and then the y dt plus y of t equals x of t. Okay, so we want to deal with this. So of course, step one, step one, so for step one now, we have to solve for the, we have to take the Laplace, right? Take the Laplace transform. Okay. Now in taking the Laplace transform, we just have um we have uh, we have the Laplace of dx dt plus x of t equals the Laplace of 2y of t. So um we have that we have y of s, which will now be common to the other side. So here now we just have the Laplace of dx dt plus the Laplace of x of t equals 2 Laplace of y of t. So since we are talking about x here, so this can be x of s, okay, minus, okay, that'll be s, x of s minus um x prime. minus x of 0 rather, minus x of 0, okay, because it's first order, so we have that. Then for the next one, we just have x of s like that, and this is equal to 2. Y of t will now be y of s. Now, here now, um, okay, for this, the initial condition, let's take the initial condition here, x of 0, let's take it to be 1. And for y of 0, for y of 0, um, let's take that also to be 1. Okay, let y of 0 also be 1. Okay, so if you have it that way, so we can fix up that. So we have x of s minus 1, s of s minus 1, then plus x of s equals 2y of s, so that we can factorize x of s now, which is this and this. So we have x of s into s plus 1, minus 1 equals 2y of s. So we can have this the way it is now. We can transfer that, right? So this is x of s, or we can make y of s the subject, all right? Let me see. 2y of s. 2y of s. Okay, so so this is x of s into s plus 1, and that is equal to 2y of s, 2y of s plus 1, so that we can have x of s, x of s can now be equal to 2y of s plus 1 all over s plus 1. So let's keep this and come back to it later after looking for the other one. So for the second equation, it's a system and they are joined together. So for the second equation, we have the Laplace of dy dt plus y of t equals x of t. Okay, equals Laplace of x of t, Laplace of x of t. So here now we have the Laplace of dy dt plus Laplace of y of t equals Laplace of x of t. So we just need to be consistent. In this case now we have dy dt, so that will just be s, that will be s y of s, okay, s y of s minus y of 0, which we already know, right, to be 1, then plus this again is y of s, and that is equal to x of s, okay? That will be x of s. So since y of 0 is 1, so we have s y of s minus 1 plus y of s, okay, equals x of s. Now, looking at what we had previously, right? We can try to make x of s the subject of formula here, so we can equate the two. So let's name this equation 1, right? So we can combine the two together. So here, let's make x of s the subject too. In fact, it's almost the subject already, but let's factorize. So we have y of s here, y of s into s plus 1 minus 1 equals x of s, okay? Or yeah, equals x of s. So we can say x of s now is equal to y of s into s plus 1 minus 1. Okay, so call this equation 2. Of course, from the first one, you see x of s is equal to the right-hand side, and we also have x of s equals this. So we can equate the two together. So equating 1 and 2, equating 1 and 2. So what that simply means is that we have x of s to be such that what we had before, 2ys plus 1 over s plus 1. Okay. 2ys plus 1 over s plus 1 is now the same thing as y of s, okay, into s plus 1, y of s into s plus 1 minus 1 now. Okay, so we can now solve for y of s easily. So let me see, what's the easiest way to handle this? We have 2y of s plus 1 equals s plus 1 into y of s plus 1 minus 1. So if we do that, that's 2y of s plus 1 equals y of s into s plus 1 squared minus s plus 1. That's s plus 1 times that minus 1. So we are looking for y of s, right? So I think it's getting tidier now. So we can transfer. So this is um so this is 1 plus s plus 1. You know, if you transfer, so if you transfer this, so we have s plus 1 going that way, and that is equal to y of s into s plus 1 squared. All right. Minus 2y of s. Does that make sense? Yeah, think so. Yep, s plus 1 comes here. Yes. So we can factorize y of s since that's what we're looking for. So this is 1 plus s plus 1, and that is y of s is common into y of s into s plus 1 squared minus 2. Okay, so this is s plus 2 equals y of s into, do we have to open that up? I think it might be necessary to open that up for sure. Okay, so this will be uh, s squared plus 2s plus 1 minus 2. When we open this up, right? S squared plus 2s times 1 plus 1. Okay, so this is s plus 2 equals y of s into s squared plus 2s minus 1, so that we now have s plus 2 divided by s squared plus 2s minus 1 equals y of s. So now we have y of s plainly. Y of s is equal to s plus 2, okay, all over s squared plus 2s minus 1. So we can then take, okay, I mean, what have I done? We have found y of s. So maybe we should, before we take Laplace, can we also find x of s? So, okay, because these are connected, right? So we can also, to find x of s, to find x of s, okay, to find x of s, we know x of s already. We can take equation 1 or equation 2. Which one is easier? I think equation 1 looks easier, all right? Equation 2 looks easier. So from 2, we can take from 2, y is s plus 1 minus 1, okay? From equation 2, x of s is equal to y of s, okay, is equal to y of s into s plus 1 minus 1. Y of s into s plus 1 minus 1. And we already have, we have y of s to be s plus 2 over all that. So x of s is equal to s plus 2, s plus 2 all over s squared plus 2s minus 1. Is that correct though? Yes, it is. Yeah, it is correct. So that's y of s now multiplied by, so this is s plus 1 all over this multiplied by s plus 1 minus 1. So we can tidy that up. So xs is equal to s plus 1, s plus 2 all over s squared plus 2s minus 1 minus 1 over 1. So that this is xs equals LCM is s squared plus 2s minus 1, okay, 2s minus 1. So that'll be s plus 1 into s plus 2, okay, minus 1 into s squared plus 2s minus 1. So xs is equal to s times 1, that's s squared plus 3s plus 2 minus s squared minus 2s plus 1, I think. Yeah, that works. So s squared plus 2s minus 1. So s squared cancels minus s squared. Then, so we have xs to be equal to 3s minus 2s is s. 2 plus 1 is 3. So we have s plus 3 all over s squared plus 2s minus 1. So we have x and y, x of s and y of s, right? So we have x of s and y of s. So let me switch gears at this point. Okay. So so x of s is equal to s plus 3 all over s squared plus 2s minus 1. And y of s is equal to y of s is s plus 2 over the same thing. So this is s plus 2 all over s squared plus 2s minus 1. So that's step one all along, right? So we take the Laplace of both sides and we take the Laplace of both sides and find x and x of s and y of s. Okay. Um, so let me call this step two now. Step two, resolve x of s and y of s into partial fractions. Into partial fractions. Okay. So we have x of s to be s plus 3 all over s squared plus 2s minus 1. And we have y of s to be s plus 2 all over s squared plus 2s minus 1. Now, I want to resolve into partial fractions. I mean, if you look at the denominator, it doesn't look like something that can be easily factorized. But then we can always find a way, right? Because we know that we can have we can find the roots, right? We can find the roots of s squared plus 2s minus 1 equals 0. Like this, s is equal to minus b. B here is 2 minus b plus or minus. B is 2. Let me just go straight. Plus or minus square root of b squared, that's 2 squared minus 4. A is 1 and C is minus 1 in this situation because A is the coefficient of S squared and C is minus 1 all over 2 times A. That's 2 times 1. So S is minus 2 plus or minus square root of 2 squared is 4 plus 4 minus minus gives 4 and we have 2. So S is equal to minus 2 plus or minus square root of 8 all over 2 and S is equal to minus 2 plus or minus 2 times 4 is 8. So that's 2 root 2 divided by 2. And what that simply means is that S is equal to minus 1 plus or minus root 2. So that is the root of S. So if that is the case, then we can go for this. For x of s, okay, for x of s, we can have x of s, which is actually s plus 3 all over s squared plus 2s minus 1 to be similar to a over, the root is, in this case, right, we can say, you see, the root is that, so it can actually be s plus 1, okay, s plus 1, okay, plus or minus root 2, okay? We can actually have it this way. So if we come here, we can have this to be s plus 1 minus root 2 plus b into s plus 1 plus root 2. So it's not straightforward, but we just can use it this way. And if that is the case, we can multiply both sides. We can multiply both sides by the denominator rather. So in that case, we have s plus 3 as usual, and that is equal to a into, so this cancels out, so we have the other one. So that is s plus 1 plus root 2. And then we have b into s plus 1 minus root 2. So that can be the way around this. So in this case, we already know that if we want to get rid of 1, we can just if we set this to 0 now, if we set this to 0, it means that once s is equal to minus 1 plus root 2 in brackets, it can eliminate whatever you have there. So we can set s to minus 1 plus root 2. That means the opposite of this one and the opposite of this. So it can easily get rid of b. So if that is the case, we just have minus 1 plus root 2 here. That's our s plus this 3. And that is equal to a into here. We have minus 1 plus root 2. Okay. That is this, only this s now, plus 1 plus root 2. So things are a bit more serious here. But b, of course, will just be 0 because minus 1 will cancel 1, plus 2 will cancel minus 2. So everything just goes to 0. So this b goes away. So we just have minus 1 plus root 2 plus 3 equals, okay, this cancels out. So we have 2 root 2. Root 2 plus root 2, that's 2 root 2a. So that a alone, okay, of course, this is still 3 minus that. This is 2 plus root 2 equals 2 root 2a. So a alone is 2 plus root 2 all over 2 root 2. Okay. What can we do with that? Wait, this is what's happening here. It's 2 plus root 2. 2 plus root 2 all over 2 root 2. What does that mean? I'm trying to see. So for a here, right? This should be, yeah, minus 1. Minus 1 plus 1 will just go. Then we have plus root 2 plus. So that's 2 root 2. So uh we can I keep forgetting that thing. We can remove the root from the bottom in short. That's what I'm trying to say. So this will just be 2 root 2 plus 2 all over 2. So the root goes away. So this will be so it's more like we're multiplying everything by root 2. So that'll be 4 down here. Okay. So we can then divide through by 2 again. So a now will be 1 plus root 2 all over 2. I hope that's correct though. I think that should be correct. Because if we set s to 0 here, so we just have, if we set s to 0 here, we have minus 1 plus root 2. So which will make this one 0. So minus 1 will cancel 1 plus root 2, we double this. Then we can rationalize. Yeah, that's the word. We can rationalize. So 2 plus root 2 all over 2 root 2. So it's more like we're multiplying root 2, root 2. So 2 times root 2 is 2 root 2. Root 2 times root 2 is 2. And 2 root 2 times 2 times root 2, that's 2 root 4, which is 2 times 2, 4. So, and that is 2 root 2. We can divide through by 2. So divide this through by 2, that's 1. Divide 2 here, yeah. And this is 4. So this is our A easily. Then on the other hand, now we can set, if we want to eliminate A, so we just set the other one. We set this to 0. That means that we have minus 1 minus root 2. So set s to minus 1 minus root 2. So if that is the case, we have minus 1 minus root 2 plus 3. Here we have s plus 3 minus 1 minus root 2 plus 3, and that is equal to a into 0, because minus 1 minus root 2, minus 1 will cancel this minus 1, minus root 2 will cancel this one. But when we come to b now, let's see what that gives. So b into this is minus 1 will cancel minus 1. Okay. Minus 1 minus root 2. Okay. Minus 1 will cancel 1. Minus root 2 and minus root 2 will be minus 2 root 2. Okay. This will be minus 2 root 2. That's how that works. So here now, 3 minus 1 is 2 minus root 2 equals, this is gone, then minus 2 root 2 b. So b will be 2 minus root 2 all over 2 root 2. Okay, all over minus 2 root 2. So that can easily be the same as root 2 minus 2 because of the minus, and we have 2 root 2. So we can rationalize also. So that is root 2 all over root 2. That's rationalization. To get rid of the root under, so this is root 2 times root 2 is 2, and this is 2 root 2 all over 2 root 4, which is 4 in short. So divide through by 2. So we have 1 minus 2, 1 minus root 2 rather, 1 minus root 2 all over 2. And that is our B. So with that, I guess we're good to go as far as x of s is concerned. I mean, we still have a long way to go, but it's fine. So we have x of s now to be the same as a. A is 1 plus root 2 over 2. So 1 plus root 2 all over 2. So the whole thing divided by s plus 1 minus root 2. Okay, s plus 1 minus root 2. Then on the other hand, we have plus 1 minus root 2 all over 2 divided by s plus 1 plus root 2. You know, based on what we have up here, okay, based on what we have here, s plus 1 plus root 2. So we can now take the Laplace, okay? We can take the Laplace of this, or the inverse Laplace rather, okay? Taking the inverse Laplace transform, okay? Taking the inverse Laplace transform, we have the inverse Laplace of x of s. That will give us what we are looking for. And on the other hand, right, we can just have 1 plus root 2 all over 2 inverse Laplace of 1 over s plus 1 minus root 2. Okay, then plus 1 minus root 2 over 2 the inverse Laplace of 1 over s plus 1 plus root 2. Okay. So, and what does that give us? Of course, we already know that if we have s plus something, it will just change the sign. So plus 1 minus root 2, we change to minus 1 plus root 2. So this simply means that x of t, let me write that in black. So x of t that we are looking for is simply 1 plus root 2, 1 plus root 2 over 2, then exponent. So plus 1 minus root 2 will now be plus 1 minus root 2 will be minus 1 plus root 2 t. On the other hand, we have plus 1 minus root 2 all over 2, then e raised power here, plus plus become minus minus, so that minus 1 minus root 2 t. So that is our x. Really, really complicated. But I mean, it's a very nice way because if we had to solve that problem directly, we may not even get. Okay, well, we can use other methods for sure. We can do eigenvalue method and eigenvector. Yes, we can do that. So for y now, I want to switch gears, you know, and use this. So we have got x of t. So let's go back to y of t. Thankfully, it's just the same kind of thing we do. So for y of s now, right? For y of s, okay, let me just go. For y of s, we have s plus 2. I'm trying to see if I can just jump and get to the final answer because they look alike a little bit, except for these two down here. So it simply means that instead of all these three we are having here, you know, we just have So instead of this minus 1 plus 3, so it will just be 1 plus root 2. And this one will also be 1 minus root 2. No, no, no. Okay, I think let me let me not be lazy. Let me just go for it. Okay. So y of s again is what is that now? Y of s. Y of s. Okay. For y of s, which is equal to s plus 2 all over s squared plus 2s minus 1, we'll have, so s plus 2 all over um, s squared plus 2s minus 1 equals, is similar to a over, what did we have the other time? A over s plus 1 minus root 2 plus b all over s plus 1 plus root 2. So that's what we have here. So we can now we can multiply through by the LCM. So we have s plus 2 equals a into s plus 1 plus root 2, then plus b into s plus 1 minus root 2. Okay, and this one will cancel out and we have that. So we can then use cover up method. So we set s to, if we want to eliminate b now, we just set s to minus 1 plus root 2. Because minus 1 will cancel plus 1, plus root 2 will cancel minus root 2. So that means that we have for s minus 1 plus root 2 plus 2 equals a into minus 1 plus root 2. That's s now. Then plus 1 plus root 2. So this cancels this. So we have 2 minus 1 is 1 plus root 2 equals 2 root 2a. So a alone is 1 plus root 2 all over 2 root 2. So which we can rationalize, root 2 all over root 2. That's how to rationalize. We want to remove the square root under. So this is root 2 plus 2 all over 2 root 4. That's 2. That's 4 in short. That's 4. So here, I don't, can we, there's no simplification we can do further, I think. So this is just going to be, um, 2 plus root 2. A will just be 2 plus root 2 over 4. So A is equal to 2 plus root 2 all over 4. So I want to suspect that the other one will be 2 minus root 2. So in that case, we have to just set S to be equal to, we want to eliminate A now. So it means S should be minus 1 minus root 2. So set S to be minus 1 minus root 2. So on the left-hand side, we have S plus 2. Okay. So minus 1 minus root 2 plus 2. And that is equal to A into 0 because all this will cancel out. And on the other side, we have 1 minus root 2, right? So we have plus b into minus 1 minus root 2 plus 1 minus root 2. Okay, so that this cancels out. So we have this is 2 here, right? This is 2. So we have 2 minus 1 again. That's 1 minus root 2. And that is equal to, this is gone. So b into, so minus root 2 into place, that's minus 2 root 2 b. So b now is equal to 1 minus 1 minus root 2 all over minus 2 root 2. So you can multiply by root 2 over 2 to rationalize. So b is equal to root 2 minus 2. Okay, root 2 times 1 is root 2. Root 2 times root 2 is root 4, which is 2. All over minus 2. That's minus 4 in short, root 2 times root 2 is root 4. That's 2. 2 times the 2 that was there before. So b can now be, because of the minus, we can have 2 minus root 2 all over 4. And that's all we can have for that. So 2 plus root 2 over 4, then 2 minus root 2 over 4. So with this in place now, you can say, so y of s is now a. A is 2 plus root 2 over 4. 2 plus root 2 over 4. All of that over s plus 1. S plus 1 minus root 2. Okay. Plus b, which is 2 minus root 2 over 4. okay, all over s plus 1 plus root 2, like that, so that we now take the Laplace inverse. So taking the Laplace inverse transform, okay, we have the Laplace inverse of y of s, and that is equal to, so not to waste time, we have 2 plus root 2 all over 4, and the Laplace inverse of 1 over s plus 1 minus root 2, okay, then plus 2 minus root 2 all over 4, inverse Laplace of 1 over s plus 1 plus root 2, like this. So we have inverse Laplace of y of s is y of t, and this is equal to 2 plus root 2 all over 4. Then e raised power minus 1 plus root 2t, then plus 2 minus root 2 all over 4, then e raised power minus 1 minus root 2t. Okay, so that is another result. So those are our solutions. Well, we may just want to do an overall, right? So in all, we have x of t equals what's that now? X of t, what's that? Yeah, 1 plus root 2, 1 plus root 2 over 2, 1 minus root 2 over 2. Okay. 1 plus root 2 over 2 e raised to power minus e raised to power minus 1 plus root 2t, then 1 minus root 2 all over 2 e raised to power minus 1 minus root 2t. Okay, we have that. And then y of t, on the other hand, is 2 plus root 2 over 4, 2 plus root 2 over 4, e raised to power minus 1 plus root 2t plus 2 minus root 2 over 4, e raised to power minus 1 minus root 2t. So that is the overall solution for this system. So, when we solve a system, we are looking for this kind of thing. So this is a very nice way of dealing with that. Okay, so that is our solution. So it can be really tedious for sure. And then let's take some practice as we get done with this. So yes, I mean, there are other forms in which these solutions can be written, right? So alternative forms, okay? Yeah, thank God I remember that. So alternative representation, alternative form 1. So this same solution can be written alternatively. Alternatively, we can have, so if you walk around it, you can also get x of t equals e raised power minus t into 3 over 2. I'm trying to see. I want to be careful about this. I want to be careful about this. Well, I mean, there are other alternative forms. It can be written, alternatively, we can write the solutions. Alternatively, we can write, we can write the solutions, in terms of cosh and sinh, or sine, or cos and sine, or cos I mean, I want to group them together, right? We can write them in terms of cos and sine, cos and sine together, or in terms of cos and sine. So it all depends on the approach we want to choose, right? So let's look at possible practice questions. Practice questions. Okay, system of ODs now. Practice. Okay, solve the following. Okay, fine. Solve the following. Solve the following. Okay, we have dx dt. That's number one. And dx dt plus 4x equals 3y. Then dy dt plus 2y equals 5x. And x of 0, x of 0 equals 1. Then y of 0 equals 0. We also have number 2, dx dt. Number 2, dx dt minus 2x plus y equals 0. Then dy dt minus x minus 3y equals 0. Then x of 0 equals 2. Y of 0 equals minus 1. We have that. We can also have question 3, dx dt plus x plus 2y equals 0. And dy dt minus 3x, dy dt minus 3x plus y equals 0. And x of 0 is 0. Y of 0 is 1. Number 4, dx dt minus y equals e raised by minus t. Dy dt plus x equals 0. So x of 0 is 1 and y of 0 is 0. So let's take a fifth one, number 5, dx dt, dx dt plus 3x plus 4y equals sine t. Okay, then dy dt minus x plus 2y equals 0. And we have x of 0 equals 0, y of 0 equals 1. All right, let me see the answers in the comment section either on Facebook or on YouTube. And also, don't forget to let me know in the comment section how helpful these videos are for you. And if there's a problem you'd like me to solve or a topic you'd like me to teach, okay? Then, of course, if you have not subscribed, please go ahead and subscribe because you have a lot more to learn right here. And if you have subscribed already, and everybody who is just subscribing, be sure to hit the notification bell so you can always get alerted each time any video is released. And don't forget to like and share so that more people can have access to this great content. Till I come your way again, keep doing maths right. Bye.